All right, good evening, everyone. Hope you can hear me. It's Tuesday night, public night at the Leitner Observatory. I'm Michael Faison. I'm the director of the Leitner Observatory, and I am not at the Leitner Observatory. I am in my backyard in Hamden, Connecticut. And it's a beautiful, clear night. If we were running public shows at Leitner and doing public observing at Leitner, we would definitely have our telescope set up for public observing. And I have my little refractor out here in the backyard looking at the moon and streaming through my little Canon DSLR camera. I can show you the setup here. Actually, I shouldn't linger too long because it's currently battery powered and it's going to turn off. I'll have to restart it for you. But we're pointed at the moon. I'll show you. So there's the telescope. It's a 90 millimeter refractor. Not a very fancy, not a very expensive telescope. I think it was $150, and that includes a basic tripod and eyepieces and so forth. That's actually a very good beginner telescope. And then I've got my Canon DSLR connected there, giving me a live view. And if you don't believe that it's a live view, I can go over here and adjust the telescope a little bit, and you see it responds in the live stream there from my camera capture. So beautiful night tonight, a little bit chilly. Oh, there, the camera just turned off. I'll switch over to the simulator and I'll go back to the camera in a minute. It's a beautiful night tonight. Getting a little bit chilly. The mosquitoes were out a few minutes ago, but they've calmed down a little bit. And what I'm going to do is, similar to last week, give a little demonstration of what's up in the sky tonight using the simulator. And you can go outside if you're in Connecticut somewhere, or in southern Connecticut where it's clear, and look up at some of the things I'm going to point out and watch the sky along with me. And if you've got a pair of binoculars, I'll point out some things that you can see with binoculars. I'm going to take a quick peek of the moon with my binoculars here. It's not really dark yet here. As you can see, there's some sun off to the west still, and the sun hasn't quite set there in the simulator yet either. I actually just recently got these binoculars. These are ridiculous. These binoculars here are kind of standard 10 by 50 binoculars that are great for astronomy and for all sorts of sports, hiking and whatnot, travel. These are 2 by 52 binoculars, so very wide field, very low magnification, and what it really does is just pump a whole lot of light into your pupils. And so it's great for looking at the sky when it's not quite dark yet, and you can see some things pop out. I've been looking for Venus to pop out in the twilight sky next to the moon, or a little bit towards the sun from the moon. And it's also great for looking at constellations, especially if you have a little bit of light pollution where you are. So I just got these and I'm having fun with them. I got them from Orion Telescopes and Binoculars. And maybe at some point I'll make a proper review video about them. So they're kind of fun. I think taking these to a dark site would be really great, because you'd see some nice Messier objects popping out in the Milky Way with the wide field binoculars. If anyone has any questions as I'm doing my presentation, feel free to post questions in the live chat, and I'll try and keep an eye on that and answer your questions as we go along. And we will go back to the telescope shortly. In my backyard is not the best place for doing astronomy with telescopes. One of the things about our neighborhood is there are a lot of trees. So you can see my view to the west is basically trees. And the only patch of sky that I have that I can really see any stars or planets or anything is more or less straight up. So I set up the telescope tonight where I thought I would have a clear view of the moon and maybe of Venus, although Venus is getting quite low these days compared to where it was a couple of weeks ago. We're heading towards Venus conjunction with the sun. and Venus is going to be heading very quickly towards being a morning star again. One thing I will say before I go on just about the software that I'm using. So I've shown this software, I showed it last time I did this live stream. It's called Stellarium, and you can download the software for free from stellarium.org. So it's pretty user-friendly. You can install it on your Mac or your Windows machine, and you can use it to learn the constellations. You can use it to find out what's up in the sky on a given night. If you start getting into more advanced astronomy and you want to plan doing astrophotography or looking for deep sky objects with your telescope, I recommend Stellarium for studying the sky. And it's free, so why not? At some point, maybe I'll talk about apps that you can get for your smartphone that are really good for learning astronomy and finding constellations and things like that. So let me go back to Stellarium. And let's see what's up in the sky tonight. So here's the sky right now. The sun's going down. I'm going to go a little bit later in the evening. Let's see. Someone's asking in the chat, where's Venus? So I can't see Venus with my naked eye yet. The sky is not quite dark enough. I strongly suspect if I were to find it, it would be right in that patch of maple tree from where I'm sitting right now. I can kind of get away with looking between the tree branches in the winter in my backyard, but in the spring and in the summer, the leaves fill in and I can't see anything other than straight up. And because the moon is a nice crescent moon tonight, there it is. This is enlarged a little bit by about a factor of 4, how it normally looks in the sky, so that it's easier to see in the simulator. But because we're about a month after the spring equinox, where the sun is when it sets and where the moon is when it's at crescent to first quarter, it's actually very high in the sky this time of year. For the same reason that the full moon is high in the sky in the winter and the full moon is low in the sky in the summer. It's actually the opposite of where the sun is in the sky. The sun is low in the sky at noon in the winter, and the sun is high in the sky at noon in the summer. If you're looking for Venus in your sky, my recommendation is to find the moon and treat the moon like a bow and arrow and shoot towards the sun, and the brightest thing that'll be popping out as twilight gets a little bit later is going to be the planet Venus. And I still don't see it here, but it's going to pop out a little bit later. I'm going to run my simulator forward to about 9:30, 10 o'clock. There we go. So Paula's asking, will we be able to see any planets? Venus is the only naked eye planet out tonight. If you were to, or at sunset, if you were to stay up till morning or get up early in the morning, you would be able to see what's up in the morning. Mars, Jupiter, and Saturn. And Mercury is kind of behind the sun right now, so Mercury would be hard to see. I really want to see some stars pop out, so let's go to maybe around 9 o'clock or so. That's good. And I'll cheat a little bit by turning off the atmosphere so it gets dark. I'm going to turn on the constellations. And what's up in the sky tonight is very similar to what's up in the sky, what was up in the sky last week. The moon is easy to find. It's so high overhead. You can track it as it goes down into the west. And the moon is in the constellation of Gemini tonight. Every night it moves one zodiac constellation to the east. So tomorrow night it'll be over here more in the direction of Cancer. Actually, not quite one every night. It's going to be about one every 2 or 3 nights. It's actually more accurate. So if we look at it tomorrow, there it is. And if we look at the next day, there it is. And now we're getting quite close to a true first quarter moon. Go back. Anyway, so once it gets dark, you'll be able to see the 2 bright stars in Gemini, Pollux, and Castor, and some of the other winter constellations that are getting really, really low at sunset. Last time I talked a bit about Cancer and Leo, so these are still good targets. And I think later on when it gets dark, I can probably point my little tiny telescope here at maybe the M44 cluster that I talked about last time, That will actually look great through my telescope. Or maybe I'll try to point at the Iota Cancri double star, which would also look good through my telescope. Now, in terms of finding some of these stars and constellations, it's always a good idea to go find the Big Dipper. So I was facing south in the simulator. I'm going to swing around and face more or less north-northeast, like so. And you can find these 7 stars, which are the Big Dipper. And if we go a little bit later in the evening, now this is going to be around 8:45 or so in the evening. It's going to be not quite overhead, a little bit north of due overhead. It's going to be easy to find tonight, so I do recommend you go out and try and find it. Once you find the Big Dipper, it helps you find a lot of other bright stars. Helps you orient yourself relative to the stars and constellations. So famously, the 2 stars at the end of the cup, right? Here are the 4 stars in the cup, and then these are the 3 stars in the handle. The 2 stars at the end of the cup will point to Polaris, the North Star, and the handle itself, if you follow the arc, it arcs around to find Arcturus, right there. Continue on, you find Spica, which is the brightest star in Virgo. And that's actually a good orientation star for finding the zodiac, or finding the ecliptic, which is where you're going to see all of the naked eye planets. So the astronomers track this blue line across the sky, not in the real sky, only in the simulator. If only there were a big line up in the sky to help me find planets. But anyway, this is the plane of the solar system. So you can see there's the plane of the solar system crossing the plane of the Earth's equator. And so that's where the sun is on the fall equinox. So the sun settled a while ago. We're about a month after the spring equinox. There's another point 180 degrees around from this point where the sun crosses the equator, the celestial equator, going from the southern hemisphere to the northern hemisphere. Here it is crossing from the northern hemisphere into the southern hemisphere. Anyway, back to the Big Dipper. So you can also use these 2 stars. So these 2 stars at the end of the cup point to Polaris. But if you use these 2 stars at the other side of the cup and go the other way, they point to this bright star called Regulus, which is the brightest star in Leo the Lion. Let's see if there are any other interesting constellations I want to point out tonight. It's lovely that what I think of as the spring constellations, like Boötes with the bright star Arcturus, and the constellation of Hercules with its really beautiful globular cluster, the great star cluster in Hercules labeled there, is coming up. So looking forward to seeing those at sunset in the coming weeks when it's dark. Let's see. I'm going to talk briefly about astronomy news. Oh, I have another question. Where's Orion? Orion is over here low in the west. So we think of Orion as a winter constellation. So it's the sun's kind of creeping around relative to the stars as the Earth orbits around the sun. And so the sun's kind of creeping in towards the constellation of Orion. The sun is actually tracking this. I said blue line before. The orange line is the ecliptic. So it's going to go through Taurus and then through Gemini, and it goes through 1 zodiac constellation per month. So in about 2 months, the sun will be sort of right about here, right in line with Orion. And so we definitely won't be able to see it. You might catch Orion right at sunset if you look in the western sky just as it gets dark. You might be able to catch it. I wanted to mention a couple of items of astronomy news. Some of you may have heard about this near-Earth asteroid that's passing by tomorrow. And let me just bring up a browser window to talk about that. So I've seen this news in a couple of different places. This is about the asteroid 1998 OR2, which is a strange name. It's a provisional designation for a minor planet. And it gets fairly close to the Earth. I think let's actually look at where it actually is. The neat thing about this asteroid is that it's gotten close enough. Well, here you see the distance is 4 million miles. And it's gotten close enough that we can get radar images of it using a radio telescope. So this is a standard thing we do with the Arecibo Radio Observatory when a near-Earth asteroid gets close enough that we could potentially get a radar echo from it that would tell us some useful information. So that's this is actually the scientists working on the planetary radar with a mask, of course. I'm in my backyard, so I'm not wearing a mask at the moment. I could grab one, I guess, if I see anyone come within 6 feet. And this asteroid is going to get quite bright tonight because it's going to get quite close. Let me describe this. Let me describe this video that you're seeing here on spaceweather.com. This looks like a sonogram or something you'd see on like a fish finder, like a sonar fish finder, and that's because it's a radar echo image. It's based on data that bounced back, radio waves that bounced back from the asteroid. They were sent out by the Arecibo telescope and came back and were detected by other radio telescopes. And this image of what the thing would look like rotating was created from those data. So that's why it has this kind of look like a echogram, because that's what it is. It's remarkably spherical to me. I'm kind of surprised. It's about 2 kilometers across, so you wouldn't want it to hit the Earth, or you wouldn't want to be around if it were to hit the Earth. It is one of these potentially hazardous objects. It does get close to the Earth, and so if its orbit changes very gradually over time, it could, perhaps in millions of years from now, collide with the Earth, but we'll be able to track it very closely over that period of time. I was actually curious to know if we could actually see it from the observatory here, and so I looked up its statistics. Anytime I want to know details about minor planets or comets or anything like that, I go to the NASA JPL website to look it up. So here's the object, 1998 OR2, and I asked for its position and its brightness and so forth tonight. This is a lot of technical data for astronomers. But one thing that's interesting over here is its apparent magnitude. This is the brightness of the asteroid tonight, 11th magnitude. So the faintest thing you can see with the naked eye is about 5 or 6 magnitude. So this is about 100 times fainter than what you'd be able to see with the naked eye. But you actually wouldn't need a very big telescope. A 6-inch telescope, maybe, or an 8-inch telescope, which are telescopes like what we set up for public night up at the Leitner Observatory, could potentially detect that. So I wanted to get permission to go up to Leitner tonight to try and live stream the asteroid. I was told no. we're still closed down. Yale campus is still closed down, but I'm hoping to get access in the not too distant future so that I can live stream public night from the Leitner Observatory. I was wondering if I could detect the asteroid with my little refractor here. That's a 4-inch refractor. And I think if I took a long exposure with a camera, I could potentially detect it. I don't think I'd be able to see it putting my eyeball to an eyepiece to try and see it. The problem is that from my backyard, it's a little bit too low. So I can see one of the bits of data in the JPL website is its elevation, which is the angle to the horizon. So it's making an angle of about 30 degrees to the horizon tonight when it's at its highest. So there are houses and trees in the way here for me, so I won't be able to see it. All right, let me see how the moon is doing. So I'm going to switch to my camera. And oh, it's still tracking. That's beautiful. The thing about this telescope, this telescope, if you buy it, from Meade, it's a Meade telescope. If you were to buy it from Amazon or OPT or any place where you can buy telescopes. It comes with basically a fancy camera tripod, which is great for visual observing. But if you wanted to track the sky, if you want to do astrophotography, you need an equatorial mount. So one of the reasons I recommend this telescope this telescope for beginners is because it's upgradable. You can take it off of the mount that comes with it, the basic beginner mount that comes with it, and you can put it on a fancier mount that will track the sky. So this telescope mount has a battery pack right here, and I can control the motion of the telescope right here. So if I press this button, you see the moon's drifting over. It only moves in one direction. If I want to adjust it the other way, I have to turn this knob right here. Let me zoom in here so you can get a little bit better view of the moon. I'm zooming in. This is just a live view from the camera. All right. You can see some of the scintillation. What was I saying about the mount? I guess I don't have anything else to say about the mount other than it's quite a good mount for what you pay. If I could only have one telescope mount for doing educational astronomy and my own fun astronomy, I would want this one. It's called the Skyview Pro mount. It's made by a company called Cinta, I think, and it's sold by a couple of different companies. I bought this one from Ryan Telescopes and Binoculars again. I think it's about $300, and then you have to pay a little bit more for the polar scope and the motors and so forth. I think you end up paying about $600 if you get sort of all the parts that you'd want for doing basic astrophotography. Like here, I can just actually snap a picture. I wouldn't want to do it this way because I'm making the telescope shake. I'd want to do shutter release or something like that. But I just snapped a picture really quickly. Let me zoom back in here. I just snapped a picture, and so I'm doing actually fairly decent basic astrophotography on the moon with a very, very simple setup. $200 digital SLR, $600 for the mount, which is a little bit expensive, and then $150 for the telescope, and it's a great setup. Someone asked, what's the model of the telescope? It's a Meade Infinity 90. So Meade Infinity 90. Meade makes a couple of good beginner refractors starting at about 50 millimeter. The 90 refers to the diameter of the lens at the front of the telescope. You know what, I bet I could zoom in one more level here on the moon and it would still look good. Well, still look good, I don't know. Really see, you can see that terminator really nicely there. You can also see the turbulence in the atmosphere really well. Look at those beautiful craters. You know, if you're interested in getting into astronomy, you can actually spend months, years, just looking at the moon. You know, when the moon is first quarter and crescent and gibbous like this, you can get a moon map and go explore the canyons and the mountains and the rills and the craters, and get a really, it's very rewarding. It's actually a really great way to get into astronomy, get into science, do astronomy with your kids. The moon is a bright object, so it's really easy to find and really easy to look at through the telescope, and really easy to get decent images with a camera. You don't even really need a camera like this. You can use your smartphone camera and hold it up to the eyepiece, and as you get better at it, you can get good images of the moon just through a camera smartphone. Someone asked, what is the mount? The mount is an Orion Skyview Pro. It doesn't have computerized go-to functionality or GPS or any of those things you really don't need. I don't recommend beginners get these fancy go-to computer controlled telescopes because well, basically they don't work that well. The mounts tend to be flimsy, and to make them really work, you need to already know a lot about pointing at a telescope and finding things in the sky. My camera's about to turn off here, so I'm going to sort of look at maybe a different part before I lose it. Let's see. Ooh, look at that. The Terminator is a really beautiful part of the moon to look at. Oh, there we go. We lost it. Let me just try to reset it. This mount is so stable. You know, I can come over here and press these buttons, and I can adjust the focus. And even with zoomed in a lot here, you know, you can see you have a pretty good view. Let's see. Someone asked a question. How often do new craters appear on the moon, and do you ever see one? Not this size, and not really, you know, big enough that you would see them with a ground-based telescope. New craters do appear on the moon, and people have seen meteorite impacts on the moon. You're more likely to see them on the dark side of the moon because you see a flash of light when the meteorite is vaporized when it hits the moon. And so you can see those changes with an orbiter on the moon, around the moon. Those craters are quite small. These craters that we're looking at here are hundreds of kilometers across, probably, approximately, of order 100 kilometers across. So they're old and big, and things don't hit the moon that often. I'm still looking for Venus. I'm going to get my owl eye binoculars here and look for Venus again. I think it's down in the trees, but the moon sure looks beautiful. Even at these are just 2x magnification, the moon looks really amazing through these. You can see more detail than you can with the naked eye. See if there are any bright stars popping out. Don't really see any bright stars popping out, and I still can't find Venus. Oh wait! I see Venus. There it is. It's down in the trees. Boy, I might try pointing my telescope at it and see if I can get an image of Venus between the trees, because we would definitely see the crescent of Venus right now. And Venus is actually fairly big in terms of its angular size, how big it appears in a telescope when you magnify it, because it's relatively close to the Earth right now as it goes between the Earth and the Sun in its orbit. I might try that while I'm doing the Planetarium show. So it's 8 o'clock now. What I've been doing is showing these Planetarium shows from Spitz Media, which is the company that built our planetarium, designed our planetarium projector and built our dome. And so I'm going to show one of these shows, which is about 20 minutes long or so. If any of you have been to the Leitner Planetarium, you know, recently in the past couple of years, you've probably seen one of these shows before. And so I'm going to show this show called Birth of Planet Earth, which is probably my favorite show right now. So you hide Stellarium, and I'm going to hide my video. If I can get that going. If anyone has questions about the show as the show's going, feel free to ask questions. And while the show's going, I'm going to try and point the telescope at another target and talk about it a little bit after the Planetarium show. This show, just a little bit about it. It's a show about the origin of the solar system, and specifically some of the events in the history of planet Earth, such as the formation of the moon and the oceans and life on the Earth. So let me just get it going here. And I'm going to turn off my mic and let you enjoy the show. I'll post a link to this stream in the comments for the video, so you can watch this show at your leisure. This is a flat screen preview movie that Spitz has made for us, and so every so often you'll see a crawl for preview only. Don't worry, I haven't pirated this video. I have permission from Spitz to show it to the public, but you will see that crawl across the screen every so often.
Gazing down from space, we marvel at Earth's bountiful oceans and continents, its life-giving atmosphere. We ask, how did our planet begin? How did it come to support life? And life to support Earth? To find out, we peer back in time, some 5 billion years ago. The story of Earth starts within a giant spiral galaxy, the Milky Way. At 100,000 light-years across, the galaxy is a cauldron of swirling dust clouds and glowing gas. This simulated view shows a 50 million year span, a cosmological blink of an eye. In that time, millions of giant stars live and die in staggering explosions called supernovae, shown here as flashes of light. They seed the cosmos with the stuff of planets: carbon, silicon, iron, and more. In one distant corner of the galaxy, a supernova shockwave slams into a cloud already rich with these elements. The impact collapses the cloud, sending stardust streaming into its core. The cloud is about as cold as the universe gets, but the tighter it's packed, the more it heats up. A storm erupts at its center, a vast raging hurricane of dust, gas, and ice crystals. In its eye, temperatures soar. A star ignites. Our sun is born. It is being fed by a slowly spinning disk, the cradle of our solar system. Within the disk, planets take shape in a long and violent process. It starts with dust, gathering into sand-like grains. They form pebble-sized objects within clouds of loose gravel. Over millions of years, gravity draws them together to form rocks, ice balls, and boulders. These objects coalesce into miniature planets, or planetesimals. One such body, the primordial Earth, is growing steadily, but its fate hangs in the balance. What began as a gentle mingling of matter is about to get ugly. A computer model recreates the first 100 million years of our solar system by simulating the interaction of dust, gas, ice, and boulders. Each flash marks a collision, Each ring tracks the orbit of a would-be planet. While some break apart in collisions, others grow large. Out on the periphery, far from the sun, a giant emerges. Jupiter. Within 1 million years of its birth, Jupiter succumbs to the gravitational pull of the inner solar system. It begins to spiral toward the sun. Scientists call Jupiter's big move the Grand Tack, named for the turn a sailboat takes into the wind. Along the way, Jupiter plows through clouds of cosmic debris. What it does not swallow, it flings out of the solar system. The closer Jupiter draws toward the sun, the more cosmic clutter it clears away. Jupiter moves all the way into the orbit of present-day Mars. Ultimately, another giant planet, Saturn, grows large enough to pull it back out. Jupiter's Grand Tack has reduced the mass of the inner solar system. Now, any planets that form there will be relatively small. That includes Earth. Earth is still just an embryo of the planet it would one day become. Now that Jupiter has moved back out, Earth and up to 30 hungry competitors are free to scour the inner solar system for scraps. They blend together. They blow apart. Which ones will survive depends on the luck of the cosmic draw. In one heady 50-million-year run, the roller derby of planets goes wild. As the remaining planets tug on one another, their orbits destabilize. A new round of collisions leaves just a handful of would-be worlds. The time is about 4.5 billion years ago. Earth may harbor volcanoes on its surface and a thin, toxic atmosphere. Our planet has so far withstood the onslaught of planet formation. It now awaits the test of its life. Another planet, about half its size, is closing in. This is Theia, a world that might have been. Instead, its journey ends here as it bears down on Earth. Imagine the view from Earth as the ultimate threat looms large on the horizon. Theia rocks Earth to the core. According to one major theory, Theia shears away a third of the planet. But instead of destroying our world, Theia becomes part of it. A computer simulation captures the first 24 hours. Debris unleashed by the collision envelops the Earth in a dense atmosphere of vaporized rock. The cloud coalesces into a ring, a belt of molten rubble. Much of the orbiting debris rains back to the surface. But within a century, what's left gathers into a single, wondrous body. Earth's companion, the Moon. After the impact, our planet is left spinning rapidly on a slightly tilted axis. The Moon orbits much closer to Earth than it does today. From its surface, our world would have filled the sky. As the Moon gradually slips into a more distant orbit, it exerts a drag on Earth. It slows our planet's spin and steadies its tilt. The Moon serves as a reminder of the cataclysm that almost spelled the end of our planet. But from here on, it would be a welcome constant, a source of stability and ultimately, beauty. For the next tens of millions of years, the steady barrage of debris from space does not let up. But asteroids don't just rain hardship. They also carry massive amounts of water. The pummeling may also have released water bound to minerals deep beneath the surface. Half a billion years after the birth of the Moon, Earth has cooled dramatically. It's now a world of water. Its seas span every horizon, broken only by volcanic islands. It's also rich with chemicals, with all the carbon, nitrogen, oxygen, iron, and more that came with the dawn of the solar system. The planet has everything it needs to accomplish its ultimate feat, producing life. But there's a problem. Its water is disappearing. The young sun is prone to powerful flares that strike the upper atmosphere. When a solar particle hits a water molecule, H2O, it can blast it apart. lightweight hydrogen wafts into space, while heavier oxygen sinks to the surface and binds with rocks. Through this process, solar radiation would ultimately strip our neighbors Mars and Venus of water. To avoid that fate, Earth is in a race to give life a foothold before its water runs out. Incredibly, life itself may hold the answer. A process that keeps living organisms alive might also keep the world wet. On the fringe of volcanic springs, they're cooking away. Proteins and nucleic acids, the chemistry of life. We don't know exactly how life sprang from cauldrons like these. What we know is that life did emerge, and that it spread thanks to a key breakthrough: the ability to turn sunlight into energy. Photosynthesis, the process that fuels plant life, made its first appearance in simple bacteria over 3 billion years ago. Using one of the world's most powerful supercomputers, scientists have sought to model its chemical secrets. Step 1 is to capture sunlight. Passing through a transparent membrane to the center of the bacteria, we encounter a cluster of spherical pods. Each one is equipped with special sensors designed to harvest solar energy. When a photon hits, it excites rings of chlorophyll molecules. This energy is transferred across a family of proteins, the machines of life. Down the line, electrons and protons carry the energy through a chain of chemical reactions. The energy driving these reactions came from the sun. The cell must now convert it into action. It's the energy stored in protons that gets things moving. Streaming into watery spaces within the cell, they flow toward a towering molecular structure. As they enter, their electrical charges turn a protein like a crank. This turning motion initiates a chemical reaction, one that is essential to all life on Earth. Two molecules join to form a third, called ATP, shown in blue. It is the universal energy currency in every cell that has ever lived. Like a biological battery, ATP stores energy captured from the sun, repackaged in a stable form that the cell can now use. To break down food, to power locomotion, to fuel reproduction, to live. ATP made it possible for microorganisms to flourish and evolve. As bacteria gave rise to plants, a more advanced form of photosynthesis released a byproduct: oxygen. Over time, this new supply of oxygen would change the chemical composition of the atmosphere and stem the loss of water. Earth avoided the fate that befell its neighbors as life spread to its every nook and cranny. Earth today, endowed with ocean, atmosphere, and land, with light and warmth, with life that's bountiful and in balance. But think of all it took to achieve that. The aftershocks of a supernova, the violence of Jupiter, a chance collision, and the gift of a moon, of water, and life. The more we're able to reconstruct our past, the more singular it seems. That is, until we realize how very many other solar systems are out there. We ask, is Earth just one of countless life-bearing worlds in a galaxy bursting with life? Or is it a wondrous twist of fate? A remarkable convergence of chemistry, energy, and chance? Our planet became a paradise. But is it the only one?
Is it the only one? Of course not. All right. Well, I managed to find Venus. You see it's getting quite dark here. I'm fading into the twilight. And I got a live view of Venus here. Let's. You can see the trees that I'm looking through. Let's see if I can zoom in a little bit on it. I'm going to switch to... There we go, a little bit faster shutter, and let's try and zoom in a couple times. So you can see it's a bit, looks a bit like the moon. It's also kind of bluish. That's one of the artifacts of this type of telescope. There is a way to fix that, and actually maybe I will do that here. Get it a little bit better centered with the zoom in. And the reason that it looks a little bit like a crescent moon is because Venus is kind of between us and the sun, not perfectly in line with the sun, of course, but we've got the Earth and then Venus and then the sun. And so the sunlit side of Venus is away from us. So we're seeing the Venus like a crescent, kind of like the way we're seeing the moon right now. Now, that yellow tint that you're seeing on the planet, I think I'm going the wrong way. It's drifting away. That bluish tint that you're seeing is a consequence of the lens that I'm using. So I can actually improve that. Hang on a second. There we go. So a little bit less artificial color and a little bit easier view of the planet. Beautiful. Looks beautiful. Now, let me see if I can adjust the... It's getting dark here. I need light. Make it a little bit... There we go. A little bit faster shutter. Get a little bit better focus. It's quite low in the sky, so I'm getting a lot of shimmering as well. It's pretty good. This is not the way I usually do astronomy, so yeah, it looks pretty good. So crescent Venus looks like a banana. It's just slightly too small to be seen with the naked eye. So the smallest thing you can see with the naked eye is about 1/30th of a degree in terms of its angular size. So the moon is half a degree in angular size, and your finger at arm's length is about 1 degree in angular size. And of course, from horizon to horizon is 180 degrees. So the moon is half a degree. Venus, when it's closest, has an angular size of about 1/60th of a degree. So that's about a factor of 2 smaller than what you'd be able to see with the naked, or what you'd be able to resolve in detail, seeing detail. Would you ever see Venus as a crescent? Some people with really good visual acuity claim that they can see Venus as a crescent. And children have better eyesight than adults, so sometimes children ask, hey, what's that banana-shaped thing up in the sky? And amateur astronomers know, oh, you're seeing Venus as a crescent. As time passes, Venus is going to continue to orbit the sun just like the Earth does, and sometimes it's closer and sometimes it's further away. The angular diameter changes by a factor of 6 as Venus gets closer and further away. So when Venus is a little further away and more fully illuminated, it has quite much smaller angular size. Looking up at the sky, it's getting nice and dark. I can see the star Procyon in Canis Minor, and I can see Pollux and Castor just above the moon, the 2 bright stars in Gemini. And oh wait, I see Regulus. I see the bright star in Leo over in that direction. And can I see the Big Dipper? The Big Dipper is kind of in the tree just exactly where I'm sitting at the moment, so I can't quite see it. Just lost my camera. I'll turn it on one more time and see if anyone has any questions. Any questions about the show, or what we're looking at through the telescope or telescopes, or anything like that? Let me zoom in a little bit. There we go. Same view I had a second ago. Adjust it a little bit. Okay, well, I'm going to post a link to that show video that I played in the live stream in the comments below. And if anyone has any questions, feel free to contact me. Our email at the observatory is info@leitnerobservatory.org. The website for the observatory is leitnerobservatory.yale.edu. So we'll be posting updates about things we're doing in the live stream, and when we'll be open again, when the building will be open again for public night, any other interesting news that's going on. If anyone has any questions, you're welcome to email me personally. My email is michael.faison, so Faison, @yale.edu, and happy to take questions about anything about astronomy, or what's going on at Leitner, or what's going on in the sky, any of that fun stuff. And as long as I can, I'll keep trying to do Tuesday night public night, even if it's online. All right, I don't see any questions, so I'm going to say good night. Clear skies, everyone. Have a great week, have a great weekend, and see you next time. Bye-bye.